All right, this lesson is part 2 of section 4.4 on rate of change and slope. Our objective for today is to determine the slope from a table of values. So it sounds like we're doing something different, but we're actually doing the exact same thing that we were doing before. In the last lesson, we learned what a rate of change is. A rate of change is the same thing as slope. So when you see the word slope, don't get confused. It just means another way of saying rate of change. So remember, rate of change is the change in the y values over the change in the x values. And we use that triangle, remember, change in y over change in x. So when it asks you in this first example here to find the slope using the table of values, really it's just asking you to find the rate of change, which we did yesterday in class. So we're going to find the change in the y values. And in this case, the y values here in the first example, these are all increasing by 7. So the change in y is 7. And we're going to put that over the change in x. The change in x here, these are increasing by 2. So the slope here is 7 over 2. I'm going to add one little thing here. We're going to get to this in another lesson, but slope, a variable that that we use for slope is m. Okay, it's kind of something you're going to see a lot, so just write this down on your paper. We'll get to that in a little bit, but I'm just going to write slope equals m. Okay. Next example here. If I look at the x values, these are all increasing by 2, right? We go up by 2. Where the y values, this time we're going down by 7. So if we find this rate of change here, this is going to be change in y over change in x. So the slope, which is the same as the rate of change, is going to be negative 7 over the change in x here, which is positive 2. So overall, that's negative 7/2. Okay? All right, now finally, for the last part of this lesson here, we're asked to find the slope between 2 points. So given the 2 points here, we can find the rate of change, right, which is just the same thing as a slope. So just because these points are listed as coordinates instead of in a table doesn't mean we don't do it any differently. So I'm just going to write it right underneath. I'm going to show 5, negative 4 underneath, almost like this is an XY table. Here's your X values, here's your Y values. So if I look at the change in my Y values over my change in X values, I will get the slope, right? So again, M is just the same thing as slope. So if I look at my change in X values, my X values, they're actually increasing by 2. I go from negative 6 to negative 4, which is an increase of 2. So my change in Y is positive, it's 2, and then if I look at my change in x here, if I go from 3 to 5, that's also an increase of 2. So this is plus 2 on both of them. So my change in x here is also positive, and I'm going to simplify that, and I'm going to simplify that to 1. So 2 over 2, that's equal to 1, or 1 over 1. Okay? All right, for my last example, I'm going to write 5, negative 7, and then underneath that, in the table form, I'll write negative 2, negative 1. So if I look at the points now, my change in y over change in x is going to be, let's look at the change in y here. For this guy, I'm going up by 6, from negative 7 to negative 1. That's an increase of 6, so that's positive 6. And for the x values, if I go from 5 to negative 2, that's a decrease, right? Because I'm going down, and that's a decrease of 7, so that's negative 7. So my slope here is negative 6 over 7. All right? Okay.